Hey guys, how are you doing? So we have started vector analysis course, and in the previous video we talked about basic vectors. Okay, so vector analysis क्या है? Fundamental है, and that is why the first series of the video I am going to create on vector analysis, and this is indispensable. Particularly it is important for mechanics. आप mechanics की problem solve करेंगे, and electromagnetism के लिए vector calculus is indispensable. And when we talk about other theories in electricity and magnetism, this is going to be an important aspect which you should have very good command over. Okay, so vector analysis में हम लोगों ने बात की थी, and let me remind you guys again, the medium of structure is going to be both Hindi and English, but by and large it is going to be English क्योंकि graduate level पे हम English को ज्यादा यूज करते हैं, and so that the utility of this course will be some sort of यूनिवर्सल. ओके, देखो मैं आपको बता देता हूं, आपके पास जो वेक्टर्स होते हैं, अगर हम बात करें, सो इफ यू वांट टू टॉक अबाउट दीज वेक्टर्स, तो वेक्टर का क्या है, मान लो दिस इज अ वेक्टर क्वांटिटी व्हिच हैज मैग्नीट्यूड एंड डायरेक्शन. ओके, so what does that mean? Magnitude simply mean its length, so this is called magnitude. Okay, and its head, what this signify? It signify its direction, है ना. तो जो इसकी डायरेक्शन कौन बताता है, इसका हेड बताता है. Normally when you were to define vector, how do you define vector? These, any vector, for that matter any quantity which is vector, it is by definition it has magnitude. Magnitude को हम क्या करते हैं, इस टाइप के ब्रैकेट में रखते हैं, and a cap, a cap is the direction. So this particular this aspect is related to magnitude, and this is related to direction. This much we have done in the previous class, है ना. What is a hat or a cap? So if you want to talk about a hat is by definition vector A and then its magnitude. Okay, vector A and its magnitude. That is the definition of a hat. Now we have already covered laws of vector algebra. तो मैं आपको एक बार फिर से बता दूं, laws of vector algebra के बारे में अगर हम बात करें तो वो क्या थे अपने पास, ये थे laws of vector algebra. Laws of vector algebra. Let me check if it is laws of vector algebra. Okay, no, it can't. Okay, let me check it. ठीक है, तो अगर ये नहीं लिखा जा रहा तो मैं इसको एक काम करता हूँ, रुको मैं फिर से लिख देता हूँ. आई वॉन्ट टू राइट इट वेरी क्लियरली, है ना. तो जस्ट अ मिनट. ओके, देखो ध्यान से समझना. लॉज ऑफ वेक्टर अलजेब्रा. ओके, लॉज ऑफ वेक्टर अलजेब्रा. एंड लॉज ऑफ वेक्टर अलजेब्रा में अगर आपको ध्यान हो, कुछ कुछ चीजें आपने की होंगी. जैसे फर्स्ट आपने क्या किया होगा, कम्यूटेटिव लॉ, है ना. तो फर्स्ट लॉ इज कम्यूटेटिव. आई एम जस्ट रिमाइंडिंग यू. और ये क्या है, एक प्रकार का रिकैप है. तो दिस इज द रिकैप ऑफ द प्रीवियस क्लास, एंड व्हाट यू आर, देखो दिस कोर्स इज going to be very problem solving kind of course. आपको बहुत सारे प्रॉब्लम सॉल्व करने हैं ना, और इसलिए आपके कमांड होने चाहिए. तो जो पहला लॉ था, फॉर एनी टू वेक्टर्स a plus b is same as if you add them b plus a. Okay, and it is going to help us to manipulate vector operations if we understand all these laws. This law is called a commutative law of vector addition. Suppose I have three vectors, then what I can do, if I wish to add first a plus b and then add another vector c, or otherwise I can first add vector b and c and then add a. This particular is called associative law. Associativity. This is called associativity. Okay, this is called associative law for addition. अगर मैं आपको बताऊं, most importantly, third law is related to commutative law of multiplication. Okay, suppose I have this lambda a, and what I can do, I can multiply it left side or right side. So it is commutative law for lambda is a scalar quantity. Okay, what it can does, देखो lambda क्या कर सकता है, इसके magnitude को change कर सकता है, इसकी direction change कर सकता है. But in particular, if we were to talk in terms of the physical quantities, it can completely change physical quantity. Okay, for example, I am giving you example. Suppose you have this momentum, and how do you define momentum? Lambda is here mass into velocity. I have two different quantities, and this is a scalar quantity, this is a vector, this is another vector. This vector is in the same direction, but the momentum is in the same direction as that of the velocity, but these two are two different physical quantities. So lambda kya kar sakta hai, it can give you a new physical quantity. That is one aspect of this. Okay, associative law agar main baat karu, what associative can be, lambda 1 lambda 2, if this is multiplies with vector a, what it can does, lambda 1 lambda 2 ek sath aa jayega, and this is what it should look like. Okay, this is the associative law for the these so called scalars. Suppose I have two scalars, lambda 1 plus lambda 2, they are multiplied with vector a. Lambda 1 will go to it goes with a, lambda 2 also goes with vector a. Okay, so this is lambda 1, this is lambda 2. Okay, there are two difference actually. तो ये क्या है, lambda 1 है, this is lambda 2. Sixth number property, if you were to talk about, suppose I have this lambda which is going with two vectors a plus b, so it will go first with vector a and then it will go with vector b. These are the important, very important aspects. Distributive law. All right. Okay, apart from this, what we are going to utilize for that matter, this is called identity element in group theory. We are going to cover zero vector is basically defined as, once you get, so even you get a plus 0 or 0 plus a, what you are going to get, you are going to get a vector. Okay, even you have this 0 vector plus a. How do you define this 0 vector? This is again important. Zero vector or null vector whose direction is, basically it is defined as a plus of minus a vector is equal to 0 vector. It is called null vector, and other vectors are called proper vector. This is null vector. Okay, so null vector has no direction. You cannot specify direction. Its magnitude is 0. Its magnitude is 0, but it is mathematical necessity for the identity element, so called identity element. So you need this vector. That is again important aspect. Okay, and for that matter, suppose if I were to do, if I were to write like this, you get minus a vector or minus a plus of a, inverse element, so called inverse element, it is going to give you the identity element. This is the basic thing about vector addition. All right, you must remember, if this is vector a, then I am going to have, if I rotate it 180 degree, this is minus a vector. Simple as it is. If this is vector a, this is going to be minus a, and if you add them, then what do you get? You get 0 vector. All right. Okay, in this class I am going to talk about unit vectors. Okay, I have already talked about unit vectors for that matter. Suppose करो unit vectors कैसे होते हैं, basically unit vectors is, this is unit vector, a cap is by definition vector a, है ना, this is the direction, है ना, identity. Okay, but unit vectors, है ना, for example unit vectors is for a does not equal to 0. तो याद रखना ये तभी ट्रू है, it is true when magnitude of this vector is non-zero, otherwise it is not defined. Okay, the unit magnitude, a vector with zero magnitude, magnitude does not equal to 0, तो यूनिट वेक्टर की सेम डायरेक्शन होती है जो वेक्टर ए की होती है. ओके, तो डायरेक्शन ऑफ यूनिट वेक्टर इज सेम, डायरेक्शन ऑफ दिस यूनिट वेक्टर इज सेम. ओके, तो यूनिट वेक्टर और डायरेक्शनल वेक्टर. ओके, अगर हम नॉर्मली बात करेंगे रेक्टेंगुलर यूनिट वेक्टर्स के बारे में, सो पर्टिकुलरली इफ यू वर टू टॉक अबाउट लेट्स से रेक्टेंगुलर पर्टिकुलर कोऑर्डिनेट सिस्टम, है ना, तो अगर मैं कोऑर्डिनेट सिस्टम की बात करूं तो दिस हैज टू डू विद रेक्टेंगुलर कार्टेशियन कोऑर्डिनेट सिस्टम, एंड इफ यू वांट टू ड्रॉ दिस कार्टेशियन कोऑर्डिनेट सिस्टम देन इट इज लाइक दिस. ओके, और like this. Okay, कार्टेशियन कोऑर्डिनेट सिस्टम, व्हाट डू यू गेट? ओके, तो अगर आप यहां पर किसी वेक्टर को स्पेसिफाई करना चाहते हो, हाउ डू यू डू दैट? सो लेट मी टेल यू, ये यहां चला गया है ना, ध्यान से देखना, दिस इज लाइक दिस, है ना, रेक्टेंगल, इसलिए इसको क्या बोलते हैं, रेक्टेंगुलर कोऑर्डिनेट सिस्टम बोलते हैं, बिकॉज इट लुक्स लाइक रेक्टेंगल, है ना, एक्स वाई जी एक्सिस और एक्स वाई जेड एक्सिस, व्हाटएवर यू कॉल इट, एक्स एक्सिस, दिस इज वाई एक्सिस, दिस इज जेड एक्सिस. नाउ इफ यू वर टू डिफाइन अ वेक्टर क्वांटिटी फॉर दैट मैटर, है ना, जैसे मैं आपको बता दूं, सपोज करो दिस इज द part you want to show vector quantity. This is a vector quantity. Okay, call this vector quantity a vector. This is vector A. What are the components of this vector? Ax, Ay, Az, है ना? तो अगर आप देखोगे, what is Ax? This the coordinate of this point are Ax 0 0. Okay, coordinate of this point it has to be, अगर आप देखोगे Ax 0, Az, है ना? Because this is, अगर आप y axis पे इसको देखोगे, I think you can do it, you know, and you can easily do it, you know. This is Az, है ना? तो Az 0 0. Okay, xyz or xyz, whatever call it. Okay, so now what I can do, I can define, you know, some vectors which are unit vectors along the direction which are perpendicular to x-axis, y-axis and z-axis, and respectively they are, you know, generally you should remember, you know, this is graduate level physics. Okay, so I am not going to I don't want you to confine to a particular coordinate system, but for that matter, you know, simply we can write I cap, j cap, k cap, and this vector. So if this is I, then Ax can be written as, you know, this vector can be written as, you know, Ax I cap. Okay, so this A vector, the whole A vector can be written as in terms of these base vectors. So I vectors, j vector, k vectors are called base vectors. They are bases. Okay, they are base vectors. They are base vectors. Okay, these base vectors are, by definition, they are unit vectors. Okay, और इनके terms में I cap, j cap, k cap. By definition, the magnitude is unity. I cap equal to j cap equal to k cap. It is unity. Okay, and importantly, इसके अलावा they are basically right-handed. They are orthogonal, है ना, mutually perpendicular. तो रेक्टेंगुलर कोऑर्डिनेट सिस्टम में जो आई जे के वेक्टर्स होते हैं, दे आर राइट हैंडेड सिस्टम में दे आर म्यूचुअली परपेंडिकुलर. ओके, तो आई जे के आर म्यूचुअली परपेंडिकुलर, तो देयर यूनिट है ना. तो आई इज, इट इज पैरेलल टू एक्स एक्सिस, दिस वेक्टर इज पैरेलल टू एक्स एक्सिस. सिमिलरली जे कैप वेक्टर, इट इज पैरेलल टू वाई एक्सिस. अगर मैं के कैप की बात करूं, इट इज पैरेलल टू जेड एक्सिस. as simple as it is. So when you were to write, you know, this vector, so this is written as ax I cap, this is ay j cap, this is az k cap. It's simply I cap जो वेक्टर है, इसको मैंने एक स्केलर से मल्टीप्लाई कर दिया ax से, and you have, you know, this length ax, है ना. Suppose if I were to multiply with it minus ax, then it means simply it goes, you know, backward, you know. That is the basic idea. Okay, all right. Or abc, okay, these are non co-planar. Okay, they are not co-planar vectors. So abc vectors or ijk vectors are non co-planar vectors. So that is how it is written as. All right, how do you define the magnitude? If you were to calculate the magnitude, you know, this is going to be, let me tell you the magnitude of this vector. If you were to ask, you know, magnitude, how do you get the magnitude of this vector? You get magnitude of this vector just, you know, a1 ax square, this is ay squared, this is az square. Pythagoras theorem we can apply, because if I were to identify, you know, this particular vector, this length is going to be ax square plus az square. Okay, and this height is again ay square. So suppose you were to calculate this a vector, तो a vector कितना हो जाएगा? This particular length is going to be ax square plus az square. Okay, there is no y, az square, and this height is ay square, and once you, you know, this is the length, by the way. Okay, this is the length, so you can do this way. Okay, once you can find out this this length, let's call this o, say some p, o p q r whatever, है ना. तो ये लेंथ कितनी आ जाएगी? अंडर रूट एक्स स्क्वायर प्लस az स्क्वायर, and then finally this height is ax, because this point is what, this point is basically ay, or in terms of coordinates 0 comma ay comma 0. Okay, how do you calculate unit vector associated with this vector? You have this vector a divided by its magnitude. Simple. Okay, तो अगर आप देखेंगे तो ये आपके पास आ गया, तो आपके पास a कैप वेक्टर कितना आ जाएगा? a कैप वेक्टर इज गोइंग टू बी ax I cap, ay j cap, az k cap under root, what do you get? Under root ax squared, ay squared, az square. Okay, These are also, let me tell you, they are non coplanar vectors. Okay, so this is vector ijk, they are non coplanar vector, they are not in the same plane. Okay, non coplanar vector, this is going to be an important aspect. I hope this is very much clear to you. Okay, now if I were to show you let's say some question on it, what kind of questions you can expect, because we are going to solve lots of questions. Okay, so you need to solve questions. For example, you have this vector. Okay, prove that magnitude of a of the vector a is a1 I cap a2 j cap. You know, बताओ कैसे करेंगे, सोच के बताओ, think about this. Okay, so suppose if you want to solve this question, you know, how do you solve this question? So you know what, so this is x-axis, this is y-axis, the coordinate of this point is ax, it is written a1. Okay, so what you can say, along this a1 comma a2 comma 0, this length, this particular length, it is going to be, ये लेंथ कितनी आ जाएगी, अगर ये a2 है और ये क्या है आपका इतना, तो ये आ जाएगा a1 स्क्वायर प्लस a2 स्क्वायर इन 3D ज्योमेट्री. So this is a2, this is a1, है ना, और they are at 90 degree by the way. Just remember this thing. Okay, they are perpendicular. So this height, यहां से यहां की height क्या है, az है ना, तो how do you get, so you have this vector a is equal to, we are going to use dot product in the next class or maybe the next to next class, and then we are going to solve it with the help of dot product, but I am not using dot product. So what is the length of a? Length of a is defined as magnitude of a. How to calculate this magnitude? Before that, you know, in the plane xy plane, in xy plane, diagonal, you know, the length of this diagonal is basically under root a1 square plus a2 square, and with this diagonal, you know, diagonal, this diagonal कहां पर है, diagonal xy plane में diagonal है, and height a3 is again a right angle triangle. ठीक है, ये भी क्या है, right angle triangle है. And what do you get? So finally what do you get? This vector a, you are going to get under root, you know, ax is so suppose you want to get this length. How do you get this length? A square equal to a1 plus a1 square a2 square plus, है ना, इसका whole square obviously. Okay, no, but you get the square and a3 square. So finally this magnitude a, it is going to be under root a1 square plus a2 square plus a3 square. This is the magnitude of it. All right, so this length OP is by definition this. Okay, you can also identify this vector, unit vector. Okay, how do you get this unit vector? तो जो unit vector है, this unit vector a cap is by definition is going to be along the direction of a. But unit vectors are going to be very very important in this, you know, discussion. I hope up until now there is no problem. Now let's solve other problems. You know, we need to solve problems before we move into the something else. Okay, given three non coplanar vector. Okay, so you have to identify what is non coplanarity. Last class में हम लोगों ने non collinear के बारे में बात किया था, and now we are talking about three non coplanar vectors ABC. ABC are non coplanar vector. What does that mean? You know, like IJK. So non coplanar vectors mean they are not parallel to the same plane. Okay, so they are not parallel to the same plane. Parallel to the same plane, that is the meaning. Okay, so if we were to define some r vector like this, you know, तो abc जो मेरे पास vectors है, what it can be, it can look like, you know, this a vector है ना, तो this a vector it can be like x time, we can okay, तो हम क्या करेंगे r vector से, what we are going to do, we construct vector r first. What do? We construct vector r. Okay, and from vector r, we what we do, we make a parallelopiped. Okay, parallelopiped क्या करेंगे हम, बनाएंगे एक, and parallelopiped जो ये है बेसिकली कौन सा वाला, this one. अगर आप देखेंगे, if this is vector c, let's say this length is some xyg, g times c है ना, तो this length, let's say this vector is zc. Okay, this was a vector, this is b vector, let's say this is y times b vector, y times b vector, and this is, let's say, x time a vector. Okay, parallelopi. All right. Okay, तो हम क्या कर सकते हैं बेसिकली, what is this or? This vector can be written as, let's say, this vector. Let's talk about this vector first. This vector can be written as OQ vector. Let's say this. What is this OQ vector? In this particular direction, अगर मुझे OR vector चाहिए, तो let's, okay, this is OT vector, same vector. तो from triangle law of, है ना, तो from triangle law of vector addition, what I can do, अगर मैं ट्रायंगल ऑफ वेक्टर एडिशन की बात करता हूं, व्हाट डू आई गेट, ध्यान से देखना, this OR vector is equal to, this OR vector is equal to OQ plus QR, OQ plus QR vector. Okay, this OR vector is R vector, है ना, OQ वेक्टर कौन सा वेक्टर है, दिस इज R वेक्टर, जिसको हमें बताना है, दिस R वेक्टर इज इक्वल टू OQ वेक्टर प्लस दिस QR vector is same as the Z time C vector. Okay, now, okay, in this AB है ना, this is, let's say, this, तो यहां पर अगर मैं बात करूं, what is OQ vector, this OQ vector is, okay, let me check, अगर मेरी गर्दन आ रही है तो I can, remove it. What is OQ vector? This OQ vector is going to be, this vector XA vector plus this YB vector, XA vector plus YB vector. Okay, तो जो मैं यहां पर ये बना रहा हूं, I hope you can get it. This length is x time A vector, this length is x time B vector यहां तक, तो OQ vector क्या हो जाएगा, XA plus YB. And now once you plug back the values, what do you get? Okay, just a minute. अगर आप वापस इसमें वैल्यूज डालेंगे, what do you get? तो you get R vector is equal to x times A vector, y times B vector, z times C vector. This is the condition. This is the condition for, non-coplanarity. Okay, तो जो R vector है, if it can be written as XA plus YB plus ZC, this is the condition for condition for non-coplanarity. Condition for non-coplanarity. ठीक है, planarity, right? Planarity. Condition for non-coplanarity. ठीक है, तो ध्यान रखना, तो where A, B and C vector, they are non-coplanar vector. They are non-coplanar vector. They are non-coplanar vector. ठीक है, in the special case ABC can be the unit vector like IJK, है ना. Okay, तो एक स्पेशल केस के बारे में अगर हम बात करें, so let's talk about a special case. We can talk about a special case when you have these three vectors A, B, C. These three vectors can be I, J, K vector, and they are mutually perpendicular vectors. What are these vectors? They are mutually perpendicular vectors. Okay, they are mutually perpendicular vectors. So you can write down, for example, this coordinate you can write down xi cap, yj cap, zk cap. And similarly, what you can do, this R can be written as x square plus y square plus z square. That is again the idea. I think this is clear to all of you. Okay, so this is the condition for non-coplanarity. Okay, now let's check this question. Prove that ABC are non-coplanar, then XA plus YB plus ZC equal to 0 implies that. Okay, suppose हम इसको क्या करेंगे, contradiction से करेंगे, है ना. So suppose contradiction. So we are going to solve it with the contradiction. Conversely, what you can do, let again in the previous class we have used the same technique. Let x equal to not 0, does not equal to 0. So if x does not equal to 0, then xa can be written as minus yb minus zc. ओके, ठीक है। तो ये क्या है बेसिकली, अगर x मान लेते हैं 0 नहीं है तो xa कैन बी रिटन लाइक दिस। ओके, व्हाट इज a वेक्टर देन? a वेक्टर कैन बी रिटन एज y by x times b vector minus z by x time c vector, and it is something like it is like this: a vector is some alpha times b, some beta times c. Okay, or it simply means a vector is in the plane of b and c. That is what the definition is, है ना? ओके, तो इसका मतलब क्या है? प्रीवियस हमें पता, वी नो, है ना? तो अगर हमने पिछले स्लाइड में किया था नॉन कोप्लानर वेक्टर्स, है ना, तो r कैन बी रिटन एज xa प्लस yb प्लस zc। ओके, तो दिस वेक्टर इज इन द, है ना, तो अगर मान लो a वेक्टर क्या है, a वेक्टर कैन बी रिटन एज द सम ऑफ b एंड c। इसका मतलब है ना, एक मिनट फिर से देखो, है ना, फाइंड एन एक्सप्रेशन फॉर एनी वेक्टर r इन 3 डायमेंशनल स्पेस। तो अगर r वेक्टर xa yb zc में है तो इसका मतलब है, या मान लो हमने पढ़ा था, वी नो, for a b non-collinear vector r vector, let's say r vector equal to xa plus yb lie in the plane of x and b, in the plane of a and b. Okay, this is what we have done earlier, right? हमने यही तो किया था पिछली बार में, है ना? तो अगर मेरे पास a और b नॉन कोलिनियर वेक्टर हैं तो इसका मतलब है what we have done it simply means this r is in the plane of this. Okay, so it means जो हमने प्रूव किया है इसका मतलब क्या हो गया? इसका मतलब ये हो गया है कि a vector lies in the plane of b and c. Okay, so it simply means a vector lies in the plane of b vector and c vector, which is contradiction, contradiction. It simply means x is 0, x cannot 0 is wrong. Okay, so it simply means, it simply translate as xa plus yb plus zc equal to 0 vector where a b c are non-coplanar. They do not share the same plane. It implies that x has to be equal to 0, y has to be equal to, and z has to be equal to 0. That's the basic idea. Okay, that is the basic idea. So I hope you have understood this question. So mathematical rigorous, this course is mathematical rigorous. It is going to be, this is the only second class. So you should be in a position to identify how to solve these problems with the contradiction, and you have to have some intuitive idea, because this course is not for mathematics, this course is for physics. So intuitively you have to think like, so if this is a vector, if these vectors are non-coplanar vector, it simply means they do not share any three-dimensional plane, because now we are particularly interested about for these beginning videos, on this, right, rectangular coordinate system. Okay, so once we'll get rid of any coordinate system, any particular choice of coordinate system, then we are going to be more abstract. But for the time being, you have this intuition. Okay, you can have this intuition. Okay, x1a plus y1b z1c barabar where a b c are non-coplanar vector. So this is very simple. Now we know what we know. We know alpha a plus beta b plus gamma c equal to 0 implies that alpha equal to 0 equal to beta equal to gamma for a, b, c non-coplanar vectors. If 3 vectors are non-coplanar, if they do not share any, they do not share any plane, then this is going to be 0. this is going to be very, very important, in our analysis. For example, if I were to write down net force equal to 0, suppose what I write, suppose I'm going to apply this concept to suppose net force acting on a system is 0 in equilibrium, and if this force is in 3 dimension, fx, fy, z cap, okay, fz k cap equal to this 0 vector, it simply means individually these forces are also 0. Okay, this is going to be our analysis in the force. You might have done this for up to your school level. Suppose karo net momentum is 0, yeah, delta p is 0, change in momentum equal to 0. It simply means delta px is 0, delta py equal to 0, delta pz equal to 0. This is an application. Similarly, you can have, this application can be if net electric field is 0. इसका मतलब है individually electric field on x-axis, y-axis and z-axis is going to be 0. That is an application, which we are going to, because this course is rigorously, mathematical rigor has, but again, intuition is indispensable, otherwise it is not going to be physics. So there is difference between physics and mathematics, very thin line difference, but we have to be intuitive also. Intuition is most important, in this course. Okay, anyways, so you should be intuitively, अगर आप rectangular coordinate system को ले रहे हो जहां पर ij के vectors we know they are non coplanar. Okay, so this is what we know so far, because these vectors, I vectors, okay, z vectors, k vectors, they are non coplanar vectors. Okay, so you are going to apply to this concept. So these are non coplanar vector. I vector, j vector, k vector are non-coplanar. They make some right-handed system orthogonally, mutually orthogonal. Okay, they are perpendicular. This is going to be our analysis. I can use, when net momentum changes 0, I can do electric field 0, magnetic field 0, for that matter, anything. But now let's get back to our question, which is very easy now. So what I can write down, x a vector, y1 b vector, z1 c vector is equal to x2 a vector plus y2 b vector plus z2 c vector. Now what I can do now, x1 minus x2 a vector, similarly y1 minus y2 v vector plus z1 minus z2 c vector is going to be equal to 0. And if these vectors a b c are non-coplanar vectors, this is what is the argument. This a, okay, this is b, this is c, they are non-coplanar vectors. So by definition, it is given that they are non-coplanar vector. And non-coplanarity, it demands this x1, okay, this non-coplanarity. So what it means, x1 minus x2 equal to 0, y1 minus y2 equal to 0, z1 minus z2 equal to 0. It simply means x1 is equal to x2, okay, and similarly this y1 is going to be equal to y2, z1 is going to be equal to z2. Simple, as simple as it is. Okay, you could have done that. Okay, now let's say, okay, r1 is equal to 3i minus 2j, and this is given r3 r, okay, what I have to find out, given that 3i cap है ना, तो अगर आप इसको देख पा रहे हो, तो जो ये क्वेश्चन है, ओके, तो आपको क्या फाइंड आउट करना है, r3, okay, magnitudes basically. Okay, this question is again easy, so I was not reading the question thoroughly. You have to find out the magnitude. What is this? r3 vector is by definition minus I cap plus 2j cap plus 2k cap. The magnitude of this vector is going to be minus 1 squared, 2 squared plus 2 squared. Interestingly ये लेंथ है तो ये पॉजिटिव आएगी. 1, 2 का स्क्वायर 4 होता है, 4 4 8 अंडर रूट 5. Okay, 2 squared 4 4 4, है ना, this is going to be 5. No, 4 4 8 plus 9 3 actually, sorry, 2 squared 4 plus 4 8 9, so this is going to be 3 unit. Okay, this is b. What is r1 vector? what is r2 vector plus r3 vector? Let's say this is vector L, कुछ भी कह दो, जो whatever you want to call it. If you want to call it vector x, you can call it vector x, you know, for the simplicity. So what is vector x? You have to just add them. 3 देखना ध्यान से, है ना? तो आप क्या करोगे, कंपोनेंट वाइज जोड़ोगे, 3 + 2 5 -1 4 I का, है ना? ठीक है, तो this is what you are going to get. Okay, -2 -4 -6 -6 + 2 -4 j का, अगेन 1 और 2 3 -3 = 0, तो 4i + 4j का, है ना? तो अगर आपके पास ये आ गया तो what do you get? The length of this vector is going to be, or otherwise if you want to write the whole thing, you know, r1 vector, r2 vector, r3 vector is going to be 4 squared plus -4 squared under root -32, 4 चौके 16 2 ना 32, 4√2, you know, so 4 squared 16 2s are 4√2. That is going to be okay. This third one is homework for you. Okay, again this third one, C part क्या है? Okay, 2r1 minus 3r2 minus 5r3. This is homework for you. Calculate and, you know, you can give the answer in the comment section. Okay, now other questions. Let's check this question. Find scalar ABC such that R4 equal to AR1, BR2, CR3. Okay, so this is the question, and now let's check. You know, this has to do with linear dependence and independence, most important concept. So this R4 vector is going to be, suppose if I am going to write, you know, this R4 vector. This R4 vector is going to be AR1. So 2AR1 vector minus 2AI1, sorry, not R1 vector. R1 vector is A का मल्टीप्लाई किया ना, 2AI का AJ का plus AK का plus BR2. Now multiply BI का plus 3BJ का minus 2BK का minus 2CI का, okay, plus CJ का minus 3CK का. Okay, and this R4 vector is given as, this is, first write down this one. Okay, this R4 vector is given as 2A, ध्यान से देखना आप, I cap and I cap polyterm, तो ये कितना आ जाएगा, 2A plus B minus 2C I cap vector. Similarly, you are going to find out for J cap, you are going to find out this vector for the K cap vector. Okay, so what do you get? Okay, so J cap minus A 3B. Okay, तो 3B मैं पॉजिटिव वाला पहले लिख रहा हूं, 3B minus A plus CJ cap. How about K cap? This is going to be A. Okay, this is A, from here minus 2B and from here minus 3C K cap. But R4 is given as, R4 is originally given as 3I cap plus 2J cap plus 5K cap. Okay, तो आपके पास ये दे रखा है. Now comparing these terms, equal terms, compare this term with 3, compare this term, comparing, है ना, तो comparing terms, comparing components of I, J, K cap. What do you get? अगर आप इसके component को compare करेंगे, what do you get? 2A plus B minus 2C equal to 3. Okay, and now what is this? 3B minus A plus C is going to be equal to 2. Okay, this is A minus 2B minus 3 is going to be equal to 5. This is the value. Okay, and now you can solve these equations and you can get, you know, the values of R4, right? So R4 is linearly dependent upon R1, R2 and R3. Okay, So now if you were to solve these equations, so you can identify, and this is for you, and let me give you the answers. A should be equal to -2 once you solve it, है ना? B is equal to you have 1, and C is going to be equal to -3. Okay, so I have, you know, answer in this particular book. Okay, so I am giving you the answers. But most important aspect here is that R4 is said to be linearly dependent on R1, R2, and R3. Okay, okay. Okay, so what I can do, uh, so R4 is basically a R1 vector plus B R2 vector plus C R3 vector, and finally what do you get? R4 vector equal to minus twice R1 plus R2 vector minus 3 R3 vector. It is called linearly dependent, it is a linear, not a square term. So R4 is linearly dependent upon vectors R1, vectors R2, vectors R3. That is important aspect. Okay, that is the most important aspect. Okay, so in general, ABC are linearly dependent. Okay, if you can find out. So this is the most important. So I am, doing it again. All right. So let me bring it to another page as well. Okay, so that so okay. All right. This it. Okay. So this can be written as R4 R4 हमने कितना लिखा था? R4 minus, anyways, R4 minus AR1 minus BR2 minus CR3 is a zero vector. So most important definition in general, है ना? I'm writing this in general. Vectors AA plus BB, है ना? The C is a scalar, big capital letters D, so on is equal to zero vector. What does that mean? Okay, so suppose you have this kind of situation, okay, and ABC are scalar, not all zero, है ना? ABC are scalar, not all zero, not all zero. So then vector ABC are called linearly dependent, है ना? Okay, ठीक है? तो vector A, B, C, so on are linearly dependent. Okay, linearly dependent linearly dependent. Oh, just a minute, let me bring this down, okay, linearly dependent if we can find out set of vectors satisfying this, है ना? Okay, so A, B, C, D, etc. are said to be linearly dependent, है ना? If I can identify, or otherwise they are linearly independent. Okay, linearly dependent. They are linearly dependent. So linear dependence is most important concept. It is going to be part of at least when we go to the quantum mechanics, for example. So we should have very good understanding of the this. I mean, what do you call it? So linear independence and linear dependence. Okay, so they are called linearly dependent vectors. Anyways, now quickly solving few questions, because this video is not going to be more than 50 minutes, and thereafter we will complete rest of the questions in the next class. Find a unit vector parallel to the resultant of find a unit vector parallel to the resultant of r1 plus r2. What is the resultant of r1 plus r2? So let's say quickly if you want to solve this question, है ना, आपको ज्यादा से ज्यादा क्वेश्चन सॉल्व करने, है ना, तो व्हाट इज द रिजल्टेंट ऑफ दीज टू वेक्टर r1 plus r2 vectors? So this r vector is going to be twice I plus 1i is equal to thrice I. 4j plus 2j is equal to 6j cap, and minus 5 plus 3 is equal to minus 2k cap. This is the resultant vector. Okay, what is r cap? By definition, r cap is r vector over r. Okay, what is r vector? 3i cap, 6j cap, minus 2k cap, and अगर आप इसका मैग्नीट्यूड देखेंगे तो कितना आ जाएगा? 3 स्क्वायर्ड माइनस 6 स्क्वायर्ड माइनस 2 स्क्वायर्ड. ओके, माइनस 2 स्क्वायर्ड. तो आप देखेंगे this r cap is going to be 3i cap minus 6j cap minus 2k cap, and this unit vector 3 squared 9, 6 squared 36, 2 squared 4. Okay, so 36 4 40 9 49 7. This is going to be the answer. This is the r cap direction. This is the unit vector, if you were to find out. So interestingly, these are the unit vector. Okay, how do you check it? If you were to check it, it should come out unique vector. Okay, this is the unit vector. Unit vector simply means r cap has to be equal to 1. R cap equal to 1. आप check करके देख लो. तो r cap vector is rewritten as 3 by 7 I cap minus 6 over 7 j cap minus 2 over 7 k cap. This is the unit vector. This is the unit vector. Okay, this is going to be the case. Now quickly, if I were to give some questions, okay, this is again very simple. If you want to apply, this is the last question for this particular session. So determine the vector having initial point p, and let's say this vector is delta r. Let's say this vector is delta r. So triangle law, if we apply triangle law to this particular session, this r1 vector, इसके जो कोऑर्डिनेट्स क्या है, x1 y1 z1 है, तो ट्रायंगल लॉ क्या हो जाएगा? ट्रायंगल लॉ अगर आप चेक करोगे, r1 वेक्टर, है ना, तो अगर आप देखेंगे, this vector is going to be r1 vector is going to be equal to delta r vector plus r2 vector. So what is the delta r vector? By the way, this is very easy question now. r1 minus r2. Okay, r1 plus delta r equal to r2. Okay, r1 plus delta r2 equal to, so okay, so this pq is going to be, okay, no, something is wrong, थोड़ा सा गड़बड़ कर दिया, फिर से देखो, this r1 vector, so this r1 plus delta r equal to r2 vector. So what is delta r vector? Delta r vector by definition r2 minus r1. Okay, तो अगर आप इसके कंपोनेंट क्या करोगे, कैलकुलेट करोगे, तो इट इज गोइंग टू बी वेरी इजी, एंड नाउ यू कैन सॉल्व इट योर ओन. सो डेल्टा आर वेक्टर के अगर मैं कंपोनेंट की बात करूं, तो इसके कंपोनेंट क्या हो जाएंगे? नॉर्मली अगर आप देखोगे तो r2 minus r1, it is going to be x2 minus x1 I cap, similarly y2 minus y1 j cap, z2 minus z1 k cap, as simple as it is. Okay, and so what is this length? This length pq is going to be under root x2 minus x1 square, y2 minus y1 square, z2 minus z1 square. Okay, that's it. All right, so we wind up this video. Thank you so very much, guys, है ना? So next time we are also going to cover few questions. We will start with questions like this, and this can be your homework problem. Okay, so with that we wind up this session. Thank you so very much, and if you really like all these videos, don't forget to comment, don't forget to tell what exactly you want. Okay, तो अगर आपको कुछ चाहिए तो you can talk about this. This is homework problem. Thank you, guys. See you until next time. Till then, goodbye.